Hi, geometry students. We're in section 7-5, and this is about parts of similar triangles. Okay, and so we have some theorems about special segments of similar triangles. So what it says here is two triangles are similar, then the lengths of the corresponding altitudes. So here's an altitude right here. An altitude is like a height. Okay, so what it says is if two triangles are similar, then the ratio between the two altitudes, AD compared to FI, is going to be proportional, right, to the ratio of the lengths of corresponding sides. So AB to FG. You also could say that instead of using AB to FG, you could say AC to FH. You could also do CB to HG. All right, so the second theorem here, two triangles are similar, then the lengths of the corresponding angle bisectors. So if we know that this line segment here bisects the angle, okay, so you can tell that by the congruent marks here. Same thing here, that these two lengths, LP divided by the RT, again, is going to be equal to the ratio of a corresponding side of the similar triangles, LM compared to RS. And then, so the difference again for this one here, this is actually bisecting the angle. 7.9 is. 7.10, if two triangles are similar to the length of the corresponding medians. Okay? Median is from a vertex to the center, or bisects the opposite side. That is called a median. And the lengths of these two medians of the similar triangles, right, are in proportion, again, with the side lengths, AB to WX. Obviously, you don't have to use AB and WX, because if they are similar, we could also say that it's equal to AC over WY, and so on. All right, so instead of proving it, let's just go right past the proof. If you want to pause, you can, and go ahead and look at that. That's proving the first 7.8 theorem. Okay, so in this problem we're trying to use the special segments in similar triangles. And so what we notice right away is that this length is 12. So we know 12 is to 8. 12 compared to 8. And we know that the length of QS to JL, right? Actually JL, right? JL to QS should be in the same ratio, or these should be proportional, because this is a median bisecting the opposite side from the vertex. Okay? So we have an expression for the JL length, and that would be x plus, looks like they're marking x plus x, or 2x. And then we have the QS length to be 5 plus 5, which is 10. So we could just cross multiply and solve for x. Let's see what they do. All right, so we have MK and TR corresponding medians, and we have JL to be 2x, and we have QS to be 10. So we have the corresponding, using our theorem, 12 is to 8 as 2x is to 10. And that's what we have on our other page. 12 is to 8, right, as 2x is to 10. And then we can solve this by cross multiplying. And we get 120 equals 16x. Divide both sides by 16, and you get x equals 7.5. All right, in the next problem, we're going to try to find the value of x using one of the other theorems. And you're going to check your progress by pausing the video. Okay, if you said 14, you are correct. Again, the altitudes, right, of these two similar triangles, we know they're similar because of the statement right here. We know that 9 is to 6. Okay, as 21 then is to x. So it looks like we can say 6 times 21 is equal to 9 times x. Now 9 is just 3 times 3. I'm doing this without a calculator then, like this. 3 times 3 times x. And if I divide both sides by 3 times 3 times x, we can do that. Or 3 times 3. That's going to leave my x. And 3 divides 6 twice. And 3 divides 21 7 times. And we have 7 times 2, which is 14. Theorem called the triangle angle bisector. An angle bisector. So this is a single triangle, not similar triangles. So an angle bisector separates the opposite side into segments that are proportional to the lengths of the other two sides. So we have our triangle JKL. Okay? And we have KM compared to the LM. So those are the lengths of the two sides that it's not necessarily the bisect of the length, but it's bisecting the angle here. That KM compared to LM is proportional to the KJ and the LJ. But only if you're bisecting the angle. So we're going to use the triangle angle bisector theorem to find x in the next problem. So we should have, based on this little picture, we should have 9 is to 6 as 15 is to x. And we can cross multiply. And then since 9 is 3 times 3, when I divide, I can divide this by 3 times 3, and then just goes into it twice here. 3 goes into 15 5 times. Looks like I get an answer of 10. Okay, check your progress. Solve for for n. Go ahead and pause your video. And if you said 15, you are correct. Okay, so what we can have here is we can have n over 5 is equal to 21 over 7. Now, since this is true, we could also have said 21 compared to the n is equal to the 7, right? Divided by the 5. So the reason why this is helpful sometimes is that you can see that what you multiply 7 by to give you 21 must be the same value that you multiply to give you n. So you have to multiply by 3. This is times 3. This is times 3. Therefore, n must be 15.